Good evening, everyone. Welcome to Yebo Tutor Livestream Help. On this beautiful Tuesday, they will be covering calculus. On our WhatsApp group, people have been asking questions on calculus. I hope you guys are ready. So if it's your first time to tune in to the channel, don't forget to subscribe, don't forget to like, don't forget to comment so that you can know if you receive the content properly. In the description of this video, there is a link which directs you guys to the WhatsApp link or WhatsApp group which we have where we send our materials, our question papers, our own notes which we have created. So guys, feel free to connect with us through that number. There's also a number on the description of video. You text it, it will direct you direct to the WhatsApp group. Also, do follow us on our Facebook account so that we can always interact with each other. So today we'll be doing calculus, which is plus or minus 35 marks, which is quite easy. So let's see how we can solve calculus fast, then we are all happy. Let's just maybe wait for like 1 minute so that few guys can join in and we can proceed together. Let's get down to the business of the day. So we are doing calculus today, as you can see on the screen. Let's maximize our screen so that everyone can see. Here we go. So question number 8. Determine f prime of x from the first principles if f of x is equal to 2x squared plus 6x. So we are now starting from question number 8. What are we given? So we are given f of x is equal to 2x squared plus 6x. Now they say that derive, or they're saying that determine the derivative of f of x from the first principles. So the moment we hear that word, our mind now will run to the formula which says that f prime of x is equal to the limit as h approach 0 of f of x plus h minus f of x divided by h. But now we don't know what is f of x plus h. So now we should look for that first. So in order for us to look this part, which means we should expand our f of x. Now let's go. F of x plus h is equal to 2. Wherever we see x, now we replace with x plus h. So this will be x plus h all squared plus 6x plus h as well. Then this will be 2. Then we expand that bracket. That should be x squared plus 2hx plus h squared plus 6x plus 6h. Great. Which is the same as 2x squared plus 4hx plus 2h squared plus 6x plus 6 of h. Then from that point now, we can see that we have our value of f of x plus h. So then from that point, then definitely we can just calculate for the value of the limit. So therefore, f prime of x, do this, okay, is equal to the limit as h approach 0. What is f of x plus h? This is f of x, so it will be 2x squared plus 4hx plus 2h squared plus 6x plus 6h minus, what is our f of x? Or f of x is 2x squared plus 6x. So I advise that the first thing which you're supposed to do on this point is to write minus, then you put brackets, you put the whole function of f of x. Why am I doing this? I'm doing this so that you guys don't do any mistakes. Let's go divide by h here. Then which is equal to the limit as h approach 0 of 2x squared plus 4hx plus 2h squared plus 6x plus 6h minus. Now we minus, then we multiply by 2x squared, so that will be negative 2x squared minus times positive 6, that will be negative 6x. Then we divide all through by h. Now they are like terms there. Let's cancel. This minus this will be 0. This minus this will also give us 0. Then we are left with few variables. So now we can proceed from that point. Again, we don't drop our limit, so we proceed as limit h approach 0 of 4hx plus 2h squared plus 6h divided by h. Then we can see here that we have a common factor on the numerator, which is h. So we take it out, then we have 4x plus 2h plus 6 divided by h. Then we can see that this h and this h can cancel each other. From that point now we are happy because now we are now left with the limit as h approach 0 of 4x plus 2h plus 6. Then now we apply the rules of the limit where now where we see h, we replace h with 0. Then we now have 4x plus 2 times 0 plus 6, which is equal to 4x plus 6. Then you have your derivative. So this was quite easy. Let's proceed. Guys, don't hesitate to ask your questions in the description of this video. I am here to listen to what you guys are saying. So if you have any question, just ask, please, so that we can assist each other. You can ask in the WhatsApp group. I also have access to the WhatsApp group so that we can assist each other. Okay, let's proceed. Now, evaluate dy over dx if y is equal to 2 squared plus 1 over 2x to the power 4 minus 3. This is now getting more interesting. So you no longer have to do what you did initially when we were looking at the perspective of first principles. Now we are using the power rule, which says that, let's write first, we are given y equal to 2x squared plus 1 over 2x minus 3. This is x to the 4. Okay, thank you. So now we can actually see that now we no longer have to work hard to get the correct answer. Now that's when we can apply what we call the power rule. So someone will be asking, what does the power rule say here? The power rule says that if we are given y equal to a x to the n, then dy over dx will be equal to a times n x n minus 1. This is the power rule, guys. So we take first step, we should take this index here, we multiply with the coefficient of x, then we subtract 1 on the index or on the power. So that will be our power rule. So now let's apply that same knowledge in solving this. So then dy over dx is equal to 2 times 2 is 4 x, then 2 minus 1 is 1, then plus, then 4 times 1 over 2 is the same as 2x, then 4 minus 1 is equal to 3. Then the derivative of a constant is always a 0. Doesn't change. It will never change. The derivative of a constant is always a 0. So guys, always know that the derivative of a constant is always 0. Always, always. So then therefore we have our dy over dx. Great. Now let's proceed to the next question. So in the next question we are given f of x is equal to that. That looks ugly. 8.2.2. So we are given f of x is equal to x cubed minus 5x squared plus 4x. Okay, divided by x minus 4. Okay, this is 4 marks. This is interesting. Now we must think before we solve anything. Let's think how we can manipulate and solve this thing. So let's go. The first thing we can see that on f of x we have a common factor on the numerator, which is x. Then now we have x squared minus 5x plus 4, all divided by x minus 4. Then we can see that this is actually trinomial, so we can solve that trinomial or that fact, and we calculate for the factors. So that will be, we still have our x minus 4 there, so definitely we have x minus 4. Then we also have x plus 1. Let's see, negative 5, 4. Then let's put negative 1 so that we still have the positive. So the factors will be negative 1 and negative 4. Great. Now we can see that this one, let me just do this. This one and this one cancels. Then we are left with f of x is equal to x minus 1, which is the same as f of x is equal to x squared minus x. Now we can apply our differential rule. This is the power rule. So then we can say therefore dy over dx is equal to 2 times 1, it's 2. Then 2 minus 1 is the same as 1. Then 1 times negative is negative 1, and 1 minus 1 is equal to 0. So our derivative only is going to be 2x minus 1. That's how we solve that problem. That's how we solve that problem there. Now let's proceed. Now moving on to the next question. Let's do this. Let's move on to the next question. 8.3. Let's do 8.3. So on 8.3, let's read it together so that it can be interesting. The tangent to the curve of y equal to, so we are given y equal to 2x squared minus 3x minus 5 is drawn at point. So we are also given a point which is 2 is to negative 3. Then now they're saying that a straight line parallel to the tangent passes through the y-intercept of the curve. Then now determine the equation of the straight line. Oh my word. Let's analyze this again. The tangent to the curve of y equal to 2x squared minus 3x minus 5 is drawn at the point 2 is to negative 3. So we have a curve which has a point of contact which is 2 is to negative 3. Let's try to visualize this. Let's visualize this. Help me visualize this. So let's say this is our curve. Then we have a point which is 2 is to negative 3 where the tangent touches. Okay, so this is point 2 is to negative 3. I'm just trying to visualize this for you guys. Now, from that point, they're saying that a straight line is drawn parallel. So this is a straight line which is parallel to that tangent passing through the y-intercept of the curve, which means this is the original curve which we were given, which is 2x squared minus 3x minus 5. So the y-intercept of this is 0 is to negative 5. Okay, when we plug in that, then we have negative 0 is to negative 5. So now, using all this information which we have here, let's now try to solve this problem, because now they've already told us many things. So the first thing, 8.3, is that we are given y equal to 2x squared minus 3x minus 5. Now, of course, if they say that the tangent, which means we are looking for the first principle or the first derivative of the function of the curve y. So dy over dx will be equal to 2 times 2 is 4 x, then 1 times negative 3 is negative 3. Now we are here. Now let's look at the gradient of this. So they say that this is at this point 2 is negative 3. So in order for us to get the gradient, it's easy. We just substitute 2 there so that we get the gradient. So now we can see that the gradient will be equal to 4 times 2 minus 3. We always look at the x coordinate of the point of product. That's why I just do something stupid here so that you guys can see proper that, okay, this is maybe our curve and this is our tangent, because we know that a tangent is a line that touches at one point. Point of contact is only one. Then they gave us the point of contact, so that is what we are working with and using it to our advantage. So now m will be equal to 4 times 2 is 8, 8 minus 3 is equal to 5. So that's the gradient. Now they say determine the equation of this parallel straight line, which is on the point 0 to negative 5. So that would be, we know that y minus y1 is equal to 5x minus x1. So y minus 5 is equal to 5x minus 0. Then now we have y plus 5 is equal to 5x, then y is equal to 5x minus 5. Someone is asking why or where am I getting this point which I substitute with, which is 0 is negative 5. So according to the English they give us, they told us that this line here, which is drawn parallel to the tangent, is passing through the y-intercept of the curve. So we were given y equal to 2x squared minus 3x minus 5. So what is the y-intercept of the this curve? We let x to be 0. Then our y will be equal to 2, 0 squared minus 3, 0 minus 5. Then we know that this will be negative 5. So the point of the y-intercept will be 0 is to negative 5. Then we substitute this point in our equation of calculating the equation of a straight line. We equate it on y1 and x1, because x1 comma y1 is the point of that straight line. Then after that we get our equation, then we live happily ever after. Is there anyone with any question, guys? Is there anyone with any question? Okay, now it seems like we are all on the same boat. We are already good. Let's proceed to the next section of the question. That is 14 marks. Now let's look at these 9 questions which we have here. Determine the point on the curve of y equal to 4 over x where the gradient of the tangent to the curve is negative 1. How can we solve that part? So we can definitely solve this. In other words, they want us to determine the gradient. This is easy, guys. This is easy. Why is it easy? Because they just want to know the point. Okay. So in order for us to solve this, how can we do this? So determine the points on the curve of y equal to 4 over x where the gradient of the tangent to the curve is negative 1. Oh, okay, so they actually told us the gradient is negative 1. So definitely we can determine the points. Why? According to what we also did early here or in this problem, then we can solve this problem quick, fast, and we are out of them. Let's solve it, let's solve it, let's solve it. Okay, cool. Now, let's go. Now, in question 9, we are given y equal to 4 over x, and they told us the gradient of this is negative 1. So now we have y equal to 4 x to the power negative 1. Then let's determine dy over dx, which is equal to negative 4x to the power negative 2. Negative 1 times 4 is negative 4. Negative 1 minus 1 is negative 2. Then they told us this gradient is always, or this gradient is equal to negative 4x negative 2 equal to negative 1. Because they told us the gradient is equal to negative 1, and you know that the dy of dx at that specific x coordinate is the gradient of the line of the circle of the curve. Then now we have divided by negative both sides, then we have 4 x to the power negative 2 is equal to 1. Now, this is the same as 4 over x squared, which is equal to 1. Then x squared is equal to 4 when we cross multiply. Square there. Then our x will be equal to plus or minus 2. So now definitely, therefore, if it's plus or minus 2, then we should calculate for the y value because they say the coordinates. So y will still be 4 over x. So when we substitute the x to be positive, we'll get positive 2. When we substitute negative 2, we get negative 2. So the coordinates which we have, therefore, will be positive 2 is to positive 2 and negative 2 is to negative 2. Then after that, you're happy. So that's how we solve that part. Now let's proceed. Let's proceed. Now moving on to 9.2. On 9.2, the graph of the cubic function with equation y is equal to x cubed plus ax squared plus bx is drawn below. Then we're given that f of 1 is got f of 4 is got to 0. F has a local maximum at point B and a local minimum at x is equal to 4. Then definitely those points are where the function is concaving up and down, and F1 and F4, those are what we call the stationary points of the graph, sort of like the axis, the x-intercept of the graph. So that A is equal to negative 9, B is equal to 24, C is equal to negative 16, only for 2 marks. Why is it 2 marks? So we are now looking at 9.2.1. So we are given that y is equal to x cubed plus ax squared plus bx plus c. So after that, now we can try to manipulate what we are given so that it can certify what we want, or it will assist us to solve this problem so that we can get to the correct answers. Definitely the first thing which you see here is that what is the value of C? What will be the value of C? 9.2.1. So that A is that and okay. So what will be our value of C, guys? Let's talk together. C, what will be our C? Okay, guys, this is easy because they've given us our stationary points, which means we can look at this in the using the formula of the turning point formula. What does the turning point formula say? It says that y is equal to a x minus x1, x minus x2, x minus x3. But in this instance, we are given x minus 1 and x minus 4 twice. So that will be e. So then y is equal to x minus 1, x minus 4 all squared. Then from that point now we can solve. Then this will be x minus 1. Then that will be x squared minus 8x plus 16. Then now we multiply this. This will be x cubed minus 8x, then minus, then we have negative 9x squared plus 24x minus 16. Then we actually seeing that our A value is 1, our B is negative 9, Our C is 24. Then our D, if they did us this, then it's going to be negative 16. So here is our equation. We have A here. So this will be our A negative, then this will be our B, this will be our C. Then we are able to certify what they wanted. Now let's proceed to the next question due to time. Calculate the coordinates of point B. Where is B? B is the maximum or the local maximum. Okay, so this is easy because we know how to calculate for the local maximum. Let's go, guys. Let's solve that problem. Let's neutralize it because the idea behind everything is for us to know how can we solve this problem in a shorter way. Solve it, let's solve it. Now we can solve that point B because you can know that's where the function concave down. That's the maximum or that's the local point. So now we have already calculated that. Let's do it red again. We have calculated that y is equal to x cubed minus 9x squared plus 24x minus 16. Then we know that dy over dx is equal to 3x, 3 times 1 is 3x, then 3 minus 1 is squared, then the same applies, that will be negative 18x plus 24. Then the derivative of a constant is always equal to 0. And we know that at local maximum, the derivative dy over dx must always be equal to 0. So let's see if I didn't do any mistakes. This will be 3x squared minus 18x plus 24 is equal to 0. Then we know that if we divide by 3, that will be x squared minus 6x plus 8 equal to 0. Then from here we can look for factors. Definitely that will be x and x. Then we have 8 and negative 6. Um, 8 and negative 6, 8 and negative 6. So that will be 4 times 2 positive. So it should be negative, negative. Yes, so it should be negative 2, negative 4. If you don't know how to find factors, use the quadratic equation automatically and you get the answers straight forward. Please make it a point that you do that so that you don't do mistakes. Okay. Then we have x is equal to 2 or x is equal to 4. So we already see that this one we have it, but we don't know this one. So therefore, our x value is equal to 2. Then we substitute x is equal to 2 in y, which is our original equation. So when we substitute 2 here, so that's where we use our ratio calculators. Then substitute 2 there, that will be 2 cubed minus 9 times 2 squared plus 24 times 2 minus 16. 2 cubed 8 minus 36 plus 48 minus 16. That would definitely be 4. So our y value is equal to 4. So therefore, point B will be 2 is to 4. Just like that, guys, then we live happily ever after. Now let's look at the two last questions. Determine the values of k for which k f of x is equal to k is only negative. That's easy, guys. We are just looking at our y-intercept, which is here, and we can see that they are saying that has negative roots. So definitely our k must be less than 16 always. That's straightforward, guys, because they've already told that they must have negative roots. So that will not give us a lot of problems. Now let's proceed. Determine the values of x for which f is concave up. When does the function f concave up? We know that f concaves up at the second derivative. So we should look for the f prime prime of x where it's supposed to be greater than 0. That's when it concaves up. Sorry. So what is f of x? F of x is equal to x cubed minus 9x squared plus 24x minus 16. Then f prime of x will be 3x squared minus 18x plus 24. Then from that part, we need to calculate f prime prime of x, which is the second derivative. That will be equal to 6x minus 18. Then we say that for concave up, always f prime prime of x should be greater than 0. So 6x minus 18 should be greater than 0. Then 6x should be greater than 18. Divide by 6. Divide by 6. Then our x should be greater than 3. Just like that, you get your marks. You are happy. So this was my calculus for you guys. If you have any question based on calculus, don't forget that you can answer on the comment section. You can answer on our WhatsApp group. You can answer on the Facebook. You can answer us on any platform, or you just text the number and ask them the question. Thank you so much, guys, for joining and for tuning. Have a great evening as we are preparing for our tests. Let's all write well and let's all write in a good way so that we pass, and next year we meet at Nelson Mandela University or any other institution which you want to go to. All the best. Have a great evening.